Welcome back to another brand new installment. As you may have already guessed from the title, we will be learning how to solve linear equations. This is a massive topic consisting of an array of subtopics or domains. So obviously this whole series will be part of several videos. So each video would focus on a different aspect of solving linear equations. I hope you will like it. Without further delay, let's get started. The first few questions all focus on how could you write an algebraic expression given a sentence of some context, okay? So here's how you do the first problem. The first problem says 18 more than a number n is 125. What is the value of n? So what is it asking is, or what is it telling you is, you have a number n, right? You have a number n, and 18 more than that number, okay, is 125. So what is n? That'll be 125 minus 18. I believe it's 107, if I'm not mistaken, right? 107 plus 18 would be 125, right? So the value of n is 107, right? Now, a great deal of these questions, if you look really deeply, there will be keywords that you have to remember. And whenever those keywords appear, that problem would have a certain face value, okay? In other words, if a certain keyword appears, the problem can only take a certain way in terms of its approach. So for instance, when you say 18 more, you're not multiplying or dividing or subtracting, you're only adding, okay? So watch out for those keywords. For instance, in this case, we clearly said 18 more than a number. That means we're adding 18 to some unknown number n, and that sum is equal to 125, okay? And that's how I was able to derive this algebraic expression, n plus 18 equals 125, right? Let's go to the second one. 20 is 7 less than twice the number w. What is w? Let's read that again. 20 is 7 less than twice the number w, right? So 20 is 7 less than twice the number w. So how do we go about doing this? So you have 20, right? When you say 20 is, that means we're literally saying 20 is equal to what? That's what it's literally translating to, okay? So 20 is 7 less than twice the number. As I said, when you see these sort of keywords, twice, 3 times, 4 times, that means you're multiplying. We know our unknown number is w, so twice the number means 2w, and we know 20 is 7 less than twice the number. That means it's 2w minus 17, right? What is the value of w? Well, if you add 7 on both sides, it's 27. So 27 equals 2w. W equals 27 over 2. That's it. It may seem easy to some of you. It may seem a little bit daunting to some of you. That's because your brain is fighting. How could I translate something in a written form into an algebraic expression? Let me tell you, no matter how much I can coach you on that concept, sometimes you have to pick up a random problem on this topic, try to solve a few, and get them wrong. Don't discourage yourself. Just keep trying. Eventually, you will start to see things make sense, right? As I said, watch for keywords. Is it saying more? Is it saying less? Okay. When it's less, you're subtracting. When it's more, you're adding. When it's something like twice or 3 times or 4 times, then you're multiplying. Obviously, we'll see something for division as well. But so far, we've looked at addition, subtraction, and multiplication. Okay. 9 less than twice x is 3 more than x. That means, again, another thing you have to know is where does one part of the problem breaks and the second part of the problem starts. Maybe that may be a catch to some of you who still don't understand how to break this problem into pieces. Is you have to figure out where can I chop so that I have two parts to a problem. That means I have two parts to the algebraic expression. We have 9 less than twice x is, again, the is a key component. So maybe you can think is the breaking point. That means this is where the equal sign comes. That means 9 less than twice x. So twice x is 2x minus 9 equals 3 more than x. It's not 3 times, it's 3 more. That means it's x plus 3 or 3 plus x. It didn't matter. So you can subtract x on both sides and add 9 on both sides, which would be 12. X equals 12. You see how I did? You have to know two things. First, you have to know where can I break the problem in two pieces. That is, I have a left side and a right side to my algebraic expression. And typically it's the is or some other variant of it is where the problem breaks into two pieces. Once you know that, then now you have two parts. Try to figure out how you can conform the sentence into an expression for the left side and do the same for the right side. And as you see me do more of these problems, you would really get accustomed to how you can break it into pieces. And that's simple as that. Okay, 80 less than 4 times the number c is, again, you see the is there. There's a recurring pattern. That means this is where the problem is breaking into two pieces. So let's focus on just this side. You don't even need to focus on the other side unless you've solved this side. So 80 less than 4 times the number c. 4 times means you're multiplying 4 times c, and 8 less than 4 times the number c. That means 4c minus 8 is equal to, now come to the second side, is 20. So there's nothing to do. Just have to substitute 20 there because that's all there is on the right side of the expression. So if you add 8 on both sides, it becomes 4c equals 28. So c equals 7. Is that simple? Maybe I have broken that barrier by identifying the keyword is. So maybe that is where, for some of you, you can know where to break the problem into two pieces. Sum of 3/4 of the number a and 24 is -9. What is the value of a? Let's read that again. The sum of 3/4 of the number a and 24 is -9. So I'm going to write something, and I want you to be honest yourself if that's what you thought. Were you thinking that for the part that says sum of 3/4 of the number a and 24 is -9? Were you thinking this? Well, I'm telling you, this is wrong. Okay, why? Because the question says the sum of 3/4 of the number a. The 3/4 is only for the a and not for the 24. Okay, if it is for the 24, then they would have said a comma 24. Okay, it's not a, it's separated by an and, so that means it's 3/4 of a, okay, plus 24 equals -9. There is a massive difference. This is the correct version. This is the incorrect version. There is a massive difference between this and this. If you solve for both of these, the a value won't be the same. Okay, just keep that in mind. So the sum of 3/4 of the number a, that's where that part of the sentence ends. It didn't say the 3/4 is carried over to 24 as well. At least it's not explicit nor implicit, nor is in any way conveying that. You may understand it that way and get it wrong because that's the way you perceive it to be. Okay, the problem is not conveying that message. So this is incorrect. This is correct. Now let's choose the correct version and proceed with the problem. Plus 24, I'm just going to put a 1 on the denominator just to make my life easy. What does that do is I can have a 4 as a common denominator. So that means it's 3a plus, it's 24 times 4, right? Which is, what is it, 96 or 24 times 4? Yeah, it's 96. So you see how I got the 96, right? 1 times 4, 4 times 24 equals -9. And 9 times 4 is 36. So 3a plus 96 equals -36, right? So 3a equals -36 minus -96 would be plus 96, which is -132. So a equals -132 over 3. I believe it's 44. So it's -44. Okay. So you could try this if you want, if you're curious, okay, what could have happened had I done this? Now, let's say if this is what you thought and you work it out. Luckily for you, unfortunately, none of the answer choices would match what you have. Then you know you have done something wrong cognitively, so you can go back and try to fix it. But keep in mind, sum of 3/4 of the number a and 24, they did not under any way say the 3/4 is applicable to both numbers. Okay, keep that in mind. Maybe it's a little tricky, but I don't think the problem is implying that the 3/4 is applying to both the cases. Let's go to number 7. The number g is decreased by 23 and then multiplied by half. The result is 8 more than twice the number g. So let's focus on this side because clearly there's a period. So this is where the first part of the expression ends. This is where the second part of the expression begins. So a number g is decreased by 23. Let's go ahead and just do that first. So you're done with this, right? And then multiplied by half. So you see how sharply contrasting here the way the sentence is written compared to the one above, right? Here it's clearly saying the half is applied to both the cases. That's what they mean by a number g is decreased by 20 and then multiplied by half means the half is carried over to both the terms. The result is, again, you can avoid the result. The is the key component here. That means anything after the is the other side of the expression is 8 more than twice the number g. So twice the number g is 2g and 8 more is plus 8, right? So let's go ahead and do this. So it will be, you have g minus 23 over 2, okay, equals 2g plus 8, right? Here you have 1. So that means it's g minus 23 equals 4g plus 16, right? So that means if you take, you can either take g to the other side, which will give you 3g. And this is, I think, what is it? 23 plus 16 is -23, -16 is -39, right? So g is -3, sorry, -13. Does that make sense? And I think that's the reason why I included problem 6 and 7 in the same screen, is because if the author of the question wants to be explicit about how to write the expression, then they would make sure to let you know that. They're not going to confuse you. So unless you think it is quite explicit that the two numbers share a common multiple, then proceed that route. If you don't, if you even slightly believe that that is not the case, then don't do it. Okay, then more often not, you're going to be right. All right, this will be the end of this domain where you're given a sentence and you're asked to write a algebraic expression. This is one of the many domains of solving linear equations. And here's the last problem on this topic. the quotient of P and Q is 12 less than 3 times the sum of P and Q, right? Again, here they're specifically saying sum of P and Q, right? Is 3. Now, for some of you wondering, what is this quotient of P and Q? How do I even imagine this? Well, always look to the answer choices for help. Now, if you didn't know what it literally meant, it literally means P over Q. And how do I know that? Well, I know what it means, but if I didn't know, I'll just look through the answer choices, and all of them have P over Q. So that's what they're referring to. So that part of the problem is simple because they all carry the same expression on the left side. So we can't really eliminate anything at this point, but it does also give you what it is that it really wants on the left side of the expression, because is our, remember, is our barrier. In other words, it's the breaking point, right? So we know the left side looks something like this. So the trick is only to find the right side, then we're done with the problem. Is 12 less than, so it's 12 less than, so that means B can be right and D can be right. It can only be A or C because it's 12 less than, that means it's negative 12. It's 12 less than 3 times the sum of P and Q, right? So here it's 3 times sum of P and Q, right? So P plus Q minus 12. So which one does it match? It matches this. Okay. All right, so that'll be the end of this video.